Math 193 in-class activity 2D, special values of sinusoidal functions. Tides refer to the rise and fall of sea levels. The National Oceanic and Atmospheric Administration collects data about tide levels from various observation points along the coast of the US and around the Great Lakes. Tidal data collected from an observation point in Boston, Massachusetts, allows us to write the following functions to predict the tide levels of February 4, 2021. And that is the function S of t equals 5 plus 5 sine pi on 6t. The tide is measured in feet squared. Data collection begins at 12 a.m. and t is measured in hours. Without computing or plugging in values of t, can you guess any heights that the tide reaches that day? I want you to pause this video and attempt the question, and we will discuss it together after that. There will be various varying answers for this question. Now, if you look at the sine function, one answer that I'm providing is that we will reach 0 feet and 10 feet. If you look at the sine function, this part cannot go above 1, positive 1, or below negative 1. And so if we take the minimum value to be negative 1 for this part, then we're going to get negative 1 times 5, which is negative 5, and 5 plus negative 5 is going to be 0 feet. Now, if we take the maximum point that it can go, we are going to get 5 plus 5, because this part is going to be 1. This part is going to be 1, and 5 plus 5 is going to be 10, and that is 10 feet. Now, if this part, if you put t to be a value, or if this part goes to like 0.5 or 1/2, then we are going to get 5 plus 5 times 1/2, which is going to be 5 plus 2.5, which is equal to 7.5 feet. And so we are going to get various answers depending on how you look at this part of the expression. Objectives for the activity. You will understand that the special angles on the unit circle correspond to special points on the graphs of the sine and cosine functions. You will be able to locate the special points on the graphs of the sinusoidal functions. You will be able to interpret the special points of a sinusoidal function in the context of a model. Use graphing technology to graph the tide levels S of t. Make sure your calculator or program is set to radian mode. Sketch one period of the graph on the axis below. What is the period of the function? And so with a scientific calculator, you should be able to plot this. Plot this, try it out, and let's see the type of graph that you will be getting. Now, if you did it well, you will see that the graph is going to start at a point here at 5. And the reason being that at time 0, when time hasn't moved, right? When this part is 0, everything here will go to 0, and you are going to start at 5. And this is going to be the nature of the graph that we are going to get. This is going to repeat itself several times along the time axis, several times this way to the right. Now the period is going to be 12 hours, right? Because after every 12 hours, the graph will begin to repeat itself. And as you can see here, from 12 a.m. to 12 here is going to be 12 hours. And so this part of the graph begins to repeat itself after 12 hours. Consider the clock diagram below. Part A. Label the times at which the tide level is lowest, highest, and the same as the starting level. Which values of t do these points correspond to? I want you to pause this video and attempt this question, and then we will discuss the solution together. Now, this is the solution. You can see that the highest is occurring at 3, the lowest is occurring at t equals 9. Now, this is the starting level, t equals 12, and one other t that looks the same as the starting level is t equals 6. Now, we obtain this from the graph. If you look at t equals 3 a.m., we are getting the highest point here, right? That is the tide level. And that is our time. So t equals 3 gives us the highest. Now, at the lowest, we are getting it at 9 a.m. That is the lowest point, and that is t equals 9. And then at the same as the starting level, this is the starting level, right? And if you look at this level, the point that is the same as the time that gives it the same as this is 6. T equals 6. And that is that. Without sketching another period of the graph, find different values of t at which the graph is highest and lowest. Justify your answer. I want you to pause the video, think about this, attempt it, and let's discuss the answer together. Now, we know that the function had its highest value when t was 3. And that is if we have 5 plus 5 sine pi on 6 times 3. This is going to give us 5 plus 5 sine of pi on 2. Now sine pi on 2 is 1. So we are going to get 5 plus 5 times 1, and that gives us our 10. And so what we want to do is that we want to find another value of t that will make this place to be 1. And if you put t to be 15, you are going to get 5 plus 5 sine pi on 6 times 15, which is 5 plus 5 sine of 3 goes into 15, 5, and then 3 goes into 6, 2. And sine of 5 pi on 2 is also going to give us -1. And -1 times 5 is going to give us -5 plus 5, which is 0. And we come to the same place as when t was equal to 9, the lowest point. And so this is what our answer should be. Consider the function s of t equals 5 plus 5 sine pi on 6t. You want to check your answers to question 3 part A by plugging into the function each of the values of t you found. Which radian angles do each of these points correspond to? I want you to pause this video, attempt the question, and then let's look at the solution together. Now let's go back a little. In the part A of question 3, we were asked to label the times at which the tide is lowest, highest, and the same as the starting level, and then to find which values of t these points correspond to. Now these are the answers that we had. Highest was t equals 3, lowest was t equals 9, and the one that gave the same starting level, that gave the same t as the starting level was t equals 6. And so what this question 4, part A, is asking us to do is to plug in these values and see if we are getting the same answers, and then also check for which angles these are occurring. And so for the highest, when we plug in t equals 3, we are getting 10 as we had on the graph, and this occurs at pi on 2. And now for the lowest, when we plug in t equals 9, we are getting 0 and occurs at 3 pi on 2. And at 6, t is equal to, this gives us the same point as the starting level, and that was when t equals 6, and it occurs at angle pi. And then last one is S12, which gives us a period, which is 2 pi. Question 4, part B. On the unit circle below, label the angles corresponding to the highest height of the tide, the lowest height of the tide, and the initial height of the tide. Do your answers to part A make sense? I want you to pause this video and then attempt the question, and let's discuss it together. Now, let's look at the answer. It says on the unit circle, we want to label the angles corresponding to the highest value of the tide and the lowest and the initial. Now you will see that this is the highest, which is occurring at pi on 2, which is true. Now this is initial, which occurs when theta is equal to 0, and it occurs also at this point. And then the lowest is occurring when theta is equal to 3 pi on 2. And this is exactly what we were seeing on the graph. So for example, we say the maximum of S of t corresponds to evaluating the sine function at pi on 2 here, which corresponds to the highest point or y value on the unit circle. Explain how we could use the unit circle to find the tide level t equals 1 without a calculator. And then using your knowledge of the unit circle and its special angles, what are some other times of the day we could determine the height of the tide? In question 6, you found that x1 equals 7.5, or the tide level is 7 feet at 1 a.m. Part A, find a value besides t equals 1 such that sine pi on 6 times t is equal to 12. I want you to read these carefully, pause the videos, and attempt the questions, and we will discuss the answers together. Now, we are not going to put in t equals 1 in the function to be able to get our answer. What we want to do is that we need an angle that would produce the same effect as when t was equal to 1. Remember, the function was 5 plus 5, the sine of sine pi on 6 t. Now, when we put t equals 1 in the earlier question, we had this to be 5 plus 5 sine pi on 6, right? And sine pi on 6 is like 0.5. And 0.5 times 5 gave us 2.5 plus 5, which gave us 7.5. And so what we want to do is we want to find an angle that gives us the same value as sine pi on 6, which is 0.5. And that angle is going to be 5 pi on 6. Okay? That is 5 pi on 6. Now, when this pi on 6 and 5 pi on 6 give us similar values. And so that is what we want to do. Number 6, explain your knowledge of the unit circle and its special angles. What are some other times of the day which we could determine the height of the tide? And so here, if you took like at 4 a.m., if you remember, t equals 4, right? If we put t equals 4 into the expression, we are going to get 5 plus 5 sine 2 pi on 3, which is that. We could put t equals anything, like 7, and we are going to get an answer. But that must be based on your knowledge of the unit circle. Because 2 pi on 3, we can easily locate it on the unit circle somewhere here. And so you want to find a value at a time that will give you something. So you can find a time that will give you something like 3 pi on 4, and you can find the exact value of that, of the sign of that, and then you calculate it. Now, part A, find a value besides t equals 1 such that sine pi on 6 times t is equal to 12. Now here, when t is equal to 1, we are going to get 5 plus 5 sine pi on 6 times 1, which is 5 plus 5 sine pi on 6. And when t is equal to 5, we are going to get 5 plus 5 sine 5 pi on 6. Provided these parts of the expressions, pi on 6 and 5 pi on 6, are going to give us the same values. Provided this and that gives us the same values, then we have found a value besides t equals 1 that gives us the same answer as t equals, yes, that gives us the same answer. And so, for example, when we put t equals 5, we are going to get 5 pi on 6 here. And 5 pi on 6 is 0.5. It is just like pi on 6. And so that answers question 7. At what other time is the tide level at 7.5 feet? Over what time interval is the tide level at 7.5 feet or higher? I want you to justify your thinking. You want to pause the video, think about this, and let's have a discussion after that. So it says, at what other time is the tide at 7.5 feet? If you remember, when t is 1, we are at 7.5 feet. And then when t is equal to 5 a.m., we are at the same point. And so all we are going to do is that when t is 5, it says at what other time? The first time was t equals 1. We slot t equals 5 into the function expression, and we are going to get 7.5. Over what time interval is the tide level at 7 feet or higher? And so at 7 feet or higher, from here to there, this is going to be between 1 a.m. and 5 a.m. And so this is the between 10 a.m., 1 a.m. and 5 a.m. These are going to be like this least height. After that, you can see that 2 a.m. we are going up, 3 a.m. we are at the highest point, 4 a.m. we are here. So 7.5 heat higher. So this is going to be our answer, between 1 a.m. and 5 a.m.